So till now we have in-depth studied about nozzle, what are different kinds of nozzle, converging and diverging type of nozzle, the pressure relation, the critical and stagnation properties, and at last we looked at a problem of choking which can occur in a flow region. So now let's look at two numerical problems. So first is we are given with dry saturated steam at 2 megapascal, which is entering nozzle and which is leaving at 0.2 megapascal. So the pressure ratio is 10 directly. We need to find the exit velocity of steam, dryness fraction, assume isoentropic expansion, that's the condition for nozzle, and we need to neglect the inlet velocity. So inlet velocity is 0. So the first thing is you must make the schematic. So this gives you an idea of what you need to find, what is given. You put down everything on a schematic, so it will intuitively come to you how to solve a problem. So we need to find the exit velocity. We have a relation of enthalpy with exit velocity. So the inlet enthalpy is directly known. For exit enthalpy, we need to use the relation of isoentropic expansion. So we find S1, that is same as S2 because of isoentropic expansion. And we have two properties at exit point, that is the pressure and entropy. So we use that two conditions to find out the dryness fraction, and we use dryness fraction to find the enthalpy at exit. We use that to find the velocity at exit. That's all we need to find. We are done. Second question is related to converging diverging type of nozzle, which is CD nozzle. So it may not be written explicitly everywhere. It is a converging diverging type of nozzle. It can be directly written CD nozzle. So my entry is at 0.8 megapascal. My exit it is 0.15 megapascal. We have isoentropic expansion with polytropic index n is equal to 1.135, which is directly given to us. We need to find the ratio of cross-sectional area at exit and area at throat for choke flow. So we need to find the ratio of cross-section at 2 points. The one of the point is the exit, another point is the area at which the throat at the throat for the choke flow. So where the choke flow should occur. So choke flow means my Mach number is 1. So we use this condition in pressure ratio, and the pressure ratio we can directly get the pressure. We use the isoentropic expansion relation to find enthalpies, velocities directly, and using the enthalpies and velocities, we know that the mass flow rate is going to remain constant because that's the condition for choke flow. After the choke flow occurs, once we have reached the Mach number is equal to 1, my velocity is not going to increase. My Mach number is not going to increase, so I can directly have the relation with respect to areas in terms of velocities and in terms of specific volume, and I can get specific volume from these conditions of pressure and inlet and exit pressures. That's all we have. From next video we can start with new topic of gas turbines.